Hi, Algebra 2, and welcome to your first video for the year. We're going to be starting out the year looking at transformations, which makes sense because throughout the year, you're going to see transformations of functions come up again and again and again. So this is your first look at them. So let's get started. You might remember from previous years that transformations change the position, size, or shape of a figure. A translation we also refer to as a slide. A reflection is a flip, and then a stretch or compression. They can be horizontal, like we'll see in a little bit, or vertical. So they can happen either way. So the first thing we're going to do is something you've probably done before, moving points around on the coordinate plane. You're given this point, -3, 4 right here, and these are the different things you're going to do with it. So you're going to end up with 4 different points when you're done. I want you to try it on your own and then come back and check when you're ready. Okay, here's what you end up with. I color-coded things to help you check your work. Essentially, if you're translating, remember you're just sliding 7 units to the right, or 3 units left and 5 units down. And if you're reflecting, you're just flipping it across that axis, so across the y-axis or across the x-axis. Okay, so this table from your book is summarizing translations. The first thing we're going to look at is horizontal translations, moving left or right. In that case, only your x-coordinate is going to change. It's easy when you look at the graph right here to see that my x value is changing, but my y value is staying the same. So it's at the same level vertically. So using symbols, we can see that our x value in our coordinate is going to change by a certain amount. They're calling it h. If you are adding, that means h is greater than 0, then it's going to move to the right. And if h is less than 0, it would look like you're subtracting, and that means it's going to move left. Very similar over here for a vertical translation. Now we're going to move up or down, and in that case, just your y-coordinate changes. The x stays the same. And so symbolically, they're showing it as adding a value of k here. If k is greater than 0, then you're going to be moving up. And if k is less than 0, it's going to look like you're subtracting, and it's going to be moving down. In this table, we're summarizing reflections. When you reflect across the y-axis, we'll talk about that one first, that's when the x-coordinate changes. And again, use the visuals, use the graphs to help you see this. If I reflect across the y-axis, right, my y value is staying the same. It's at the same level horizontally, but my x value is changing. It's becoming its opposite. And so that's what they're showing here. By the x becoming negative x, that's its opposite. Similarly, if you reflect across the x-axis, the y-coordinate is going to change, and the y-coordinate becomes its opposite, and that's what they're showing right there with symbols. We're going to be translating this function 3 units to the right and 2 units up, and we're going to do those at the same time. So first thing I would do is find points on your graph that are going to be easy to use, and then for each point, move it 3 units to the right, 2 units up, draw your new function, try it on your own, and start again when you're ready. So this is what your new function should end up looking like. It should look like the whole thing just moved 3 units to the right and 2 units up. The other way to do this is to create a table of values of those points that you used. This will come in handy sometimes if your function is a little more complicated or if you're doing a different type of transformation. Then what you do is you just change your x and y values based on what you did. So we did 3 units to the right, so that moved our x values by 3, and we moved 2 units up, so that moved our y values by 2, or added 2. And so then you fill in what you have here. If I take -1 plus 3, that would be 2, 0 plus 2 is 2, and I just keep going down and having my new points. Whoops. And you can see that these coordinates match up with the coordinates on our new function. Next, we're going to do a reflection, and we are only going to reflect across the y-axis, so I'm going to cross this one out. Again, I'm going to find those points that I thought were easier to use, and we're going to start flipping those points across the y-axis. So this point right here is going to end up right there. This point ends up staying the same because it's on the y-axis. This point is going to get flipped to right over here. And lastly, this point would get flipped to right there. And if I connect these, I should see just a flipped version of my previous line. And again, we could also do this using a table, so I put in those original points that I had. And we know that when we reflect across the y-axis, and it's easier to see once you've done this, that your x value is the one that changes. Your x value becomes its opposite, or its negative. And so if I fill in my new points, I'm really just changing those x values to their opposite. And you can double check that, yep, that's where those points ended up. Next, we're going to be looking at stretches and compressions. In this table from your book, they're really summarizing everything for you, and this is something to refer back to a lot. Stretches and compressions happen when you end up multiplying your coordinates by a number. So a horizontal stretch is when each point is going to be pulled away farther from the x-axis. So your x value is what's changing. It's going to be multiplied by a number. In the example here, they're multiplying it by 2. So each of your x values is now going to be twice as far away from the y-axis as it originally was. If the number you're multiplying by is between 0 and 1, in other words, a fraction, it's going to make it compress or get closer to the y-axis. So in this case, they're multiplying the x values by 1/2. So now they're half as far away from the y-axis. So now it looks like it's compressed. In a vertical stretch or compression, it's the y-axis or y value that's changing. And the y value gets multiplied by a number that's going to move it away from the x-axis. So in this case, it's being multiplied by 2. So each point is now twice as far away from the x-axis as it originally was. And if it's a fraction, it's going to get closer to the x-axis. And so now each point is closer to the x-axis than what it originally was. Sometimes it can be difficult to figure out if this was a horizontal or vertical stretch or compression. Your key is to look at where your lines cross your axes. So in this case, you'll notice that the points on the y-axis are not changing. It's the points on the x values that are changing, and so it's a horizontal change. When your points that are crossing the x-axis don't change, you'll notice that it means that the y values of those points are changing, and so it's a vertical stretch or compression. All right, in this example, we're going to do a stretch, and just because of space on our graph, we're only going to do the vertical stretch by a factor of 2. So again, let's find points, and I know these don't line up exactly, but let's use nice numbers to make this a little bit better. So when I'm writing down my points here, I have the origin, I have 2, 2, and I have -1, 3. This is where using a table is going to be very handy. We're doing a vertical stretch, so that means the y values are going to be impacted. They're the ones that go vertically, and there's going to be stretched by a factor of 2, so your y values are going to be multiplied by 2. And so in my new points, my x values are still the same, but my y values are all multiplied by 2. So those are my new points to plot. So I'll put those on the graph, and there we are. Oh, I'm going to do one more point out here. So that would be 6, 2, and there we go. All right. And we draw our new graph, and we see that, yep, it does look like it went under a vertical stretch. So we're good to go. And notice how it was a factor of 2. So your points are all now twice as far away from that x-axis as they originally were. In this example, we're going to be doubling the price of a can of paint. We could use a table for this, but I also want to just think through this logically. So first, if a can of paint costs $50, if we double that, that one can of paint is going to cost $100. If 2 cans of paint cost $100, double that, 2 cans are now going to cost $200, and so on and so forth. So now we have this, and we have to decide what type of transformation this was. So I'm thinking that each point is now twice as far away from my x-axis, and so it's really that same transformation we just did. It's that vertical stretch by a factor of 2. Good work. You made it through your first video for Algebra 2. Let me know if you have any questions as you continue on with your work, or if there's any questions from the video. Nice job, guys.